All right, so we're going to continue with identifying reactions. And we're also going to complete these reactions, especially replacement reactions. Replacement reactions are problems where you got, for instance, if you have a single replacement, it comes in different ways. You could have AX reacts with B to form BX and A. You could have A plus BX yields AX plus B. There are a few other ways, but what we're going to do here today is I'm going to start it off with AX plus B, and then you're going to have to finish the rest. In a double replacement reaction, you have AX and BY yield AY and BX. Well, what I'm going to do with you guys is I'm going to give you the reactant side, and then you've got to finish it. So that's what we're going to do today. All right, so let's do an example of this. This should go by pretty quick. All right. So, example. This will be a single replacement. And I need you to balance it too. Solid lithium reacts with liquid water to produce what? Now, this is where you get a little tricky. What could be the products? Well, one thing you all definitely need to keep in mind, and this is going to be very helpful for you in the future. We've done this reaction before down here. This is the reaction for producing water. But there's another way to produce water, an easier way. Here's what you need to remember. A hydrogen ion reacts with a hydroxide ion, and it still produces water. You have two hydrogens, you have one oxygen. So there's more than one way to actually produce H2O. And so in this particular problem, you're going to want to go with the one I just wrote. Hydrogen reacts with hydroxide to yield H2O. So lithium is a cation. It is found in group 1. It has a positive charge. Hydrogen, just the hydrogen ion, H+, that is a cation. The rest of it is OH, which is a -1 charge. So if you break it up like this, what would lithium be more likely to bond with? The hydrogen ion or the hydroxide ion? Yeah, positive and negative goes together. So the hydrogen is going to leave the hydroxide. They're going to separate. And the negatively charged hydroxide is going to bond with the positively charged lithium on the product side of the reaction. So we're going to have lithium hydroxide, LiOH, and all that's left is hydrogen. What do you remember about hydrogen, Arshan? It has to be H2. It is diatomic. If you just did that, that is wrong. Have no fear of ice cold beer. Has to be H2. So this is the complete equation, but it's unbalanced. So you always have to take the time to balance this. So let's figure it out. I want to see if you guys can do it without doing a scoreboard. You have one lithium on the left, one on the right. That looks good. You have two hydrogens on the left, three on the right. And you have one oxygen on each side. Anybody have a recommendation on what coefficient we should use and where should we place it? Derek? If you're wrong, we'll erase it and do it over. Big deal.
I think you should do a 2 in front of the H2O.
Okay.
And
So,
then,
go on.
that would make the O's even, the oxygen oxygens,
Yeah.
but that would make the hydrogens uneven because the left side would have 4, the right would have 3.
Okay, so what do you propose we do about that? So what Derek has done so far, he has fixed the oxygen issue. He has evened out the oxygens. That's good. But in doing so, he's made the hydrogens uneven. So what do you think we should do next?
Finding common multiple.
Well, you got 3 hydrogens on the right, 4 on the left. I would put a 2 right here. And then now the oxygen number is even. How many oxygens are on each side? How many hydrogens are on each side?
4.
But what about lithiums? We have 2 on the right, 1 on the left. So what should we do over here on the left? Is it even? Yes. So what's the ratio? 2 to 2 to 2 to 1. Yeah.
Why couldn't it just become H2 plus Li2O and then make it 2O? Like, why does it bond to the
Because O is not the polyatomic ion here. You had water. An oxygen ion and a hydrogen ion don't make water. It's hydrogen ion and a hydroxide ion.
So because we're talking about ions,
Yes.
hydroxide and hydrogen?
Yes.
Okay.
Now, you guys don't have to worry about the states on these. You're not going to be expected to know that, but I will tell you whenever you see hydroxide is aqueous. And what state of matter is hydrogen? It's a gas. It's the most abundant substance in the universe. Now, let's get to continue about activity series and replacement reactions. So let's do another example. I got solid copper reacts with silver nitrate. I need to know my products. Now, I want you guys to help me figure out something here. What is the charge of nitrate? Correct. So how many nitrates are here? So how many silvers are there? So what must the charge of the silver be? That's right. That's the logic that you have to use. Yes, Nicole? It's always positive 1, but sometimes it's not going to be that simple. Now, I'm going to tell you that this is going to be copper 2. Just throwing it out there. If it's necessary for me to tell you that, I'll tell you that. And in this case, it is necessary for me to tell you that. So I'm going to tell you that this copper is copper 2. We won't write a positive 2 charge on there, but that's going to come in very important right now. Copper has a positive charge, silver has a positive charge, and nitrate has a negative charge. So which dance partner is going to be going solo here on the product side, the silver or the nitrate? Yeah, so copper is going to be bonded to silver. But hold the phone. I told you that's copper 2. What's the charge of the nitrate? So how many nitrates do you need? How do you write multiple polyatomic ions? You now have 2 nitrates. And then silver will be by itself over here. That is the unbalanced equation. But let's balance this thing. And then we'll move on. How many coppers are there on each side? 1 and 1. How many silvers are on each side? 1 and 1. How many nitrates are on each side? 1 and 2. So how do we balance the nitrate? What do you do? What coefficient should you use and where should you place it? Scout? What is the name of AgNO? I want you guys to, instead of say AgNO3, things like that, I want you to use the names. What would you call it? So now say with confidence. That is correct. Silver nitrate. So she says put a 2 coefficient in front of that. So now we have 2 silver nitrates. The nitrates are balanced, but now the silvers are out of whack. So put a 2 right there, and now you're good. So what is the ratio here? 1 to 2 to 1 to 2. Okay. Questions so far?
why do you do like copper with nitrate, not nitrate with silver?
Because nitrate was with silver on the reactant side. Copper's over here by itself. So it's A plus BX yields AX plus B.
And, because it has to be a single replacement.
That's right. This is a single replacement reaction. Anything else? What?
I thought that wouldn't there be 6 oxygens because 3 times 2?
There's 2 nitrates, and so this 2 coefficient here distributes across everything. So what is 2 times 3?
I was talking about on the other side.
Yeah, there's 6, but also look on the left. We put a 2 coefficient in front. What's 2 times 3?
6.
That's also going to be 6 oxygens.
And then 2 nitrates. I mean, nitrogen.
2 nitrogens. That's right. Got it?
Yeah.
All right, Sean.
If you ran like the ratio and it was like 4 to 2 to 2 to 4, and could you make it into 2, 1, 1, 2?
Yeah, that's called the empirical formula versus the molecular formula. Empirical is the reduced, molecular is the way it actually is before you reduced it.
Okay.
We're not there yet, but yes. Okay, so now, guys, we have something called the activity series. So this is going to be about, can one substance replace another? What group are the halogens? Group 17. So the way this works is, let's say Nick is sitting in his chair, and I'm bigger and I'm stronger than Nick, so I'm going to kick him out. Nick, get out of this chair. So I'm going to get him out. And I'm going to sit in his chair. And then Nick comes along and says, Dorsey, get out of my chair. I'm like, oh. I can move him. He can't move me. There are going to be metals on here where, let's say A can replace B, but B cannot replace A. And if that happens, you're just going to write no reaction. So I want you guys to write this list down, and I will provide this list for you if you need it on the test. So the way this works is, the higher the metal, the more reactive it is. And the rule here, here's the golden rule. A higher metal can replace a lower metal. But, what do you think the rest of that statement is going to be? A lower cannot replace a higher. And the same goes for halogens. Yes, Trey.
What do you mean by like higher? Like,
I'm about to show you. I'm not done yet. All right, so here we go. Lithium, rubidium, potassium, calcium, sodium, magnesium, aluminum, listen carefully, manganese. I can't tell you how many people get magnesium and manganese confused. Don't let it happen to you. Zinc, iron, nickel, tin. What is tin? Tin is SN, right? Lead, PB. I'll put the odd ones in parentheses. You know. Wait, no, wrong one. Tin is PB. This is no, tin is SN. Lead is PB. That's not very obvious. Fe is iron, in case you didn't know. You should know that one. Silver, platinum, and gold. So here's how this goes, guys. Trey said, what do you mean by higher and lower? Take a look at this list. Can calcium replace sodium? Right here. Can calcium replace sodium? Yeah. Can sodium replace calcium? No. Any element that is higher than the other on this list, and it is in that order, can replace it. So, for instance, calcium can replace nickel. But nickel trying to replace calcium, that's not going to work. And so if you ever have a problem where you are asked to do something where you're trying to replace a metal that is not allowed to replace a non-metal, for your products, you're going to put NR, no reaction. Now for the halogens, it's pretty much the same way. You have fluorine, chlorine, bromine, iodine. Can fluorine replace bromine?
Yeah.
Can bromine replace fluorine? No, it cannot. So don't overthink this. It's simply where any element that is below another can be replaced. But an element cannot replace any elements that are above it. Iron can replace nickel, tin, lead, silver, platinum, gold. But tin cannot replace anything that is above it. Yes, Nicole?
So with the halogens, it just kind of goes in order.
Yes.
It doesn't really deal with the metals. Is there actual like reason or just memorize it?
It's just, yeah, you don't have to memorize this. I will provide you the list. Yes, Arshan?
Are the halogens, like, do they interact with the metals in any way? Or is it just like
Yeah, they can form an ionic bond, but you're not going to be doing that with this. It's either going to be all metal to metal or halogen to halogen.
Okay.
So this is the most active up here. And these are most active up here. And then at the bottom of the list are the least active. And then we have least active. So gold can't replace anything. And anything can replace gold. So let's do an example. Silver and copper to nitrate. How do I know that that is copper 2 nitrate and not copper 1 nitrate? Jade? What do you mean the copper has a 2? Where do you see a 2 on the copper? That's not to the copper, that's to the nitrate. Here's how you all have to know. Everyone from Jay to Francis and everyone in between needs to be able to see this. You ready? We'll do this again. What is the charge of that nitrate? You have to have that memorized. -1. How many nitrates are there? So what is -1 times 2? -2. So the entire negative side of that compound is -2. How many coppers are there? No. There's 1 copper. If there were 2 coppers, there would be a 2 subscript right after the copper. Let me ask you this. When you see water, H2O, how many hydrogens are in water? How many oxygens are in water? If there's no subscript that follows the element, Carson, then there is only 1 of that element. So there's only 1 copper. What must the charge of that copper be to balance out the -2 charge of the 2 nitrates? +2. We name metals after their charge. So copper with a +2 charge is called copper 2. If it had a +1 charge, it would be copper 1. There's some like cobalt. Cobalt can be called up to 6. You can have a +6 charge. So that is how you determine this. So that is why this compound here is called copper 2 nitrate. And then you just have silver. So I'm going to ask you to complete this equation. The silver is a metal. Would it have a positive charge or a negative charge? Correct? The copper, would it have a positive charge or a negative charge? Correct. And the nitrate, what does that have? Good. So who's going to be replaced? This is a single replacement reaction. Which element on the reactant side is going to be replaced? That's right. But here's where you have to look at your list. Does silver have the ability or like the authority to replace copper? So look at your list. Copper's not on the list. Did I skip it? I did skip it. That's darn it. All right, I'll throw it in there. Fix it. It's right after lead. That's my bad. Just squeeze it in there. So does copper have the ability, or excuse me, does silver have the ability to walk up to copper and say, get lost?
No.
No, it doesn't. So here's what you're going to write. You're going to love these problems. You ready? NR.
Oh, that's perfect.
No reaction. Can't happen. Can't happen. Now let's try one with halogens. I have fluorine, which is a gas, react with sodium bromide, which is aqueous. What would the charge of fluorine be if it were an ion? Negative. How about sodium? Positive. And how about bromine? Good. Now, who is going to get replaced? Is fluorine going to replace sodium, or is fluorine going to replace bromine? Fluorine is going to replace bromine. Does fluorine have the authority to replace bromine? Yes. So you will switch them out. So sodium is going to be bonded with fluorine, but I need you guys to assure me that they're at the proper ratio. What is the charge of a sodium ion? +1. What is the charge of a fluorine ion? -1. Are they balanced out? Yes. And how do I write bromine? Br2, because it is diatomic. Is this equation balanced? No, it isn't. So let's see if you can do it without any scoreboards. You have 2 bromines on the product side, 1 bromine on the reactant side. You have 2 fluorines on the reactant side, 1 fluorine on the product side. So let's try putting a coefficient right here. That's going to even out our fluorine situation, but now we have 2 sodiums. So let's put a coefficient there, and it is balanced. 1 to 2 to 2 to 1. So in this problem, you would not be writing NR. You would be finishing the equation. Let's do one more. Bromine gas reacts with, Scout, what's the name of NaF? You got it. Sodium fluoride. Can it yield products? So let's find out. What would the charge of bromine be? Positive or negative? Negative. What would the charge of sodium be? Positive. What would the charge of fluorine be? Negative. So what is bromine going to replace? The fluorine or the sodium? Bromine would hypothetically replace the fluorine. But look at your list. Does bromine have the authority to replace fluorine? No. So what do you write? NR. No reaction. In this one, it was vaporized. It's a liquid at room temp. Doesn't mean you increase the temp. You could have increased it. Okay. What time is it? Oh, we got time. All right, let's do 3 more practice. I want you guys to do these on your own. You're going to get like 5 minutes. All right, here we go. Practice problem A. Practice problem B. Practice problem C. If you're not allowed to replace, write NR. Yes, right.
Do you think you could like post like a thing that we could print out that has a list?
You could just get your phone and take a photo of the page, or you can go to Google and type in activity list or activity series.
Okay.
There's lots of resources.
So like within this, where would we in this?
The metals and they're not. There's two separate lists. The metal list and the halogen list. Yes.
I don't know, like, FPCU for what the charge is.
How do you know? You have to look at the other element it's bonded to.
Yeah,
Oh, that? Okay. Guys, on part A, I want you to just assume that the iron is positive 2. Just assume it's positive 2.
What about the magnesium? Let's see.
Well, magnesium, you should know.
Oh, is that, I think, let's do it.
Two more minutes.
Oh, yeah.
All right, here we go. So for A, I just want you to assume that iron is a positive 2 charge. Is that copper 1 or copper 2? How do you know it's copper 2? It's because there's one copper bonded to one sulfate. And what is the charge of a sulfate? So what must the charge of the copper be? That's right. Good, 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 good. Now I want you to just assume the iron is positive 2. So you need to look at your list. Does iron have the authority to replace copper? Yes, it looks like it does. Iron is above it. So you can replace it. So copper will be by itself, and iron will be bonded to sulfate. Is copper diatomic? No, so just leave it like that. Is it balanced? Yeah. Okay, part B. Does bromine have the authority to replace chlorine? No. Bromine is below chlorine, so no reaction. Does magnesium have the authority to replace aluminum? Yes. What is the charge of a magnesium ion? What is the charge of an aluminum ion? What is the charge of a chlorine ion? Oh, you're correct, -1, excuse me. Do you see why there are 3 chlorines there? I hope so. It's to balance it out. So magnesium will be bonded to chlorine. At what ratio will that happen? Magnesium is positive 2, chlorine is -1.
1 to 2.
1 magnesium to 2 chlorines. That would be correct. And then you have aluminum sitting all by itself. Yes.
So subscript can go down, but coefficient stays.
Yes. Well, you're not, the subscripts aren't going down per se. It's just you're making the individual compounds balanced. You can put coefficients in front to make the whole thing's balanced. So this equation is not balanced. We have 3 chlorines on the left, 2 on the right. So I think we need to have a common multiple of 6. There you go. 3 to 2 to 3 to 2. Okay. Any questions? Any questions? Okay, note that I ask questions and no one responds. Okay, let's do a double replacement reaction this time. I want you guys to finish the reaction here. You'll never get this. You guys will never get this. That's a double replacement reaction, the reactant side. See if you can do the product side. You'll never get it. Ever. Okay. Is calcium a positive or negative? Is hydroxide positive or negative? Is hydrogen positive or negative? Is chlorine positive or negative? What will calcium be with on the product side? Calcium is going to be with chlorine. Okay, I need you guys to tell me the ratio. What is the charge of a calcium ion? Positive 2. It's found in group 2. How about chlorine? Negative 1. So which one do you need more of? You need 2 chlorines to balance it out. So that's calcium chloride. So what is the other product? Oh, throw that back in my face. Yes, it would be water. You know, I see some students do. I want you guys to learn this. Here's what I've seen before. HOH. Don't do that. It's water. H2O. Okay. Now, here's another one. Well, don't worry about balancing it. We need to move on. I'm sure you can balance it out. Full faith in you. Okay, finish it. Yep. You should be able to tell by looking at the compound.
Oh, it's,
Can metals change charges between the reaction. Okay, so it would stay the same charge.
I want you guys to tell me the name of NaOH. Anyone not named Nicole, Arshawn, Francis? What is the name of and Kevin? And what is NaOH? Tim. Sodium hydroxide. What is the name of CuCl2? This is tougher. David?
It's not, is it sodium chloride or is it,
Cu?
oh, copper. Copper chloride?
You're leaving something out.
Copper dichloride?
No. You don't use prefixes when you have a metal and a non-metal. Trey?
Is it chloric acid?
Chloric acid. That's CuCl2. Chloric acid would be HClO. That's copper. Yes.
Copper 2, 4.
Yes. Why did you say 2?
Because with metals, you have to include if it's 1, 2, or 3, or whatever.
Because many metals can have variable charges, so you need to change it. Okay. What will sodium be dancing with on the product side, guys? And what ratio do I have to have them? 1 to 1. And what will copper be dancing with on the other side? Hydroxide. What will the ratio be? 1 to 2. Now, here's what I'm going to tell you. In this reaction, check this out. This is aqueous. This is aqueous. This is aqueous. And this is a solid. Whenever you have a reaction in which the two reactants listed here are aqueous, one of the other products is aqueous, but the second product is a solid, this is known as a precipitate. A precipitate, by definition, is a solid produced in a chemical reaction. What do we call snow and rain and sleet and hail? Precipitates, because they fall. If you actually had this reaction happening in a container, the precipitates fall to the bottom of the container. So a precipitate is simply when a solid is formed in a chemical reaction. Yes, Nicole?
So when different parts of the different reactions or products are aqueous, does that mean water is in the reaction?
Yeah, but it's not part of the reaction.
So how is it aqueous when there's no water in the reaction?
No, I said there is water. It's just, it's aqueous because you're placing it in a water environment. It has the ability to dissolve in water. That's what that means.
So is it currently dissolved in water or it just has the ability to?
It is not in water. If it's water, it would say in water, this is mixed with that. That's what your problems will say.
It just has the ability to.
Yes, it has the ability to dissolve in water, but it's not in water in this example. Okay? We have time for maybe one more. Maybe one more. Maybe. No, we don't. Okay. Now, before I finish off with you guys, and if you're listening at home, if you go in your PowerPoint, slide 18 times 2, 36. Page 35, I think. Look up here. I have a step-by-step breakdown of how you do these double replacement reactions. If you get lost, you need to use that little step-by-step tutorial. Tomorrow we will begin section 3 of this unit.